In this video, I will be explaining problems from parabola, ellipse, and hyperbola. In the last video, I had covered circles. So there were 5 questions that were asked from these topics: two from parabola, two from ellipse, and one from hyperbola. So let us just start with the problems. So the first question says, if there is a circle with its center at the focus of a parabola, we know that this is the kind of parabola. Y square is equals to 4ax is like this. So y square is equals to 2px is also like that, where just 2p is equals to 4a or p is equals to a by 2. We know that when a parabola is like y square is equals to 4ax, the focus is what? A comma 0. Since p is 2p is equals to 4x, so p is not, so p is 2a. A should be equals to p by 2. So the focus of this parabola is p by 2 comma 0, right? So p by 2 comma 0, this is the center of the circle, and it's also given that this circle touches the directrix of the parabola. We know that directrix of the parabola is a straight line perpendicular to this x-axis, and the distance of this is origin. If this distance is p by 2, this is also p by 2, right? This is also p by 2. So this is the center and this circle touches this line. So circle is something like this, right? It doesn't look exactly like a circle, but it's a circle, believe me. And this is a parabola. So this is the center. What should be the radius? This distance plus this distance should be equal to the radius. This is p by 2 and this is p by 2. So the radius is equals to p by 2 plus p by 2. Radius is p. Now we know that the center of the circle is p by 2 comma 0. So x minus p by 2 whole square plus y minus 0 whole square is equals to p square. This should be the equation of the circle, and this y square is equals to 2px is equation of the parabola. So now we need to find out the points of intersection of these two curves. It's very easy to do it. Just substitute y square is equals to 2px into this. So x minus p by 2 whole square plus 2px is equals to p square. Or there is another way. Instead of like solving these two equations, I can just substitute p by 2 comma 2p in these two equations, right? Whichever one satisfies is the solution. So the first one is p by 2 comma 2p. So put p by 2 here. So p by 2 minus p by 2 is 0. So 0 square is 0. 2p minus 0 is 2p. So 2p square is 4p square. 4p square is not equal to p square. So this option is gone. Next is minus p by 2 comma p. So minus p by 2 minus p by 2 is minus p. Minus p square is p square. Plus p minus 0 whole square is p square. So p square plus p square, which is also not equal to p square. This is also gone. P by 2 comma minus p. So p by 2 minus p by 2 is 0. So 0 square is 0. Minus p minus 0 is minus p square, which is p square. So this equation is satisfied. But let us see if this satisfies this parabola. So minus p whole square is equals to 2p into p by 2. So p square is equals to p square, right? So this is satisfying. Let us check for this as well. Minus p by 2 minus p by 2 is minus p whole square is p square. P square plus minus p whole square is p square. So p square plus p square is 2p square, which is not equal to p square. So we know that this is the correct option. In the exam, I would say instead of solving this equation, we can also do this. But let us try to solve the equation as well, just for the sake of clarity as to how this should work. A square plus b square minus 2ab will become minus px plus 2px is equals to p square. So x square 2px minus px is px plus p square by 4 minus p square is minus 3 by 4 p square is equal to 0. So x is equals to minus b is minus p, plus minus square root of b square, which is p, minus 4 into a is 1, and c is minus 3 by 4 p square. So divided by 2a, so 2. Minus p plus minus square root of p square plus 3p square by 2. Minus p plus minus square root of 4p square is 2p by 2. So x is equals to either minus p plus 2p by 2, comma minus p minus 2p by 2. So which is what? P by 2 or minus 3p by 2. If x equals to p by 2, what is y? Y square is equals to 2px. Y square is equals to p square, so y is equals to p. And y square is equals to 2px, so minus 3p square. This is positive, but this is negative, so this is not a solution. So the solution is p by 2 comma p or minus p, because this is y square is equals to p square. So y can either be p or minus p. So we have two solutions, p by 2 comma minus p, and which is obvious because this is symmetrical. So this and this are there. So this is p by 2 comma p, and this should be p by 2 comma minus p. Okay, so let us move on to the next problem. If the tangent drawn at the point 4, 8 on the parabola meets the parabola this at A and B, then the midpoint of AB is what? Y square is equals to 16x. We are drawing a tangent to that at this point 4, 8. We know that the slope of the tangent can be found out by using dy by dx. So I differentiate this 2y into dy by dx. Differential of 16x is 16. So dy by dx is equals to 8 by y. And the point is given as 4, 8. So slope at the tangent at this point should be what? Dy by dx is equals to 8 by 8. In place of y I put 8. So slope is 1. So slope is 1 and it is drawn at this point. So I know the equation of the tangent, right? Y minus 8 by x minus 4 is equals to 1. So y is equals to x plus 4 is the equation of the tangent. Now this tangent is intersecting this parabola y square is equals to 16x plus 80 at 2 points A and B. I am being asked the midpoint of AB. So if this is the equation of the parabola, it will be something like this parabola y square is equals to 16x plus 80. This is the equation y is equals to x plus 4, x is 0 then y is 4. These are the 2 points A and B, and we are being asked the midpoint of AB. Okay, so how do I do it? If this point is x1 y1 and this point is x2 y2, so the midpoint C is equals to x1 plus x2 by 2 comma y1 plus y2 by 2. How do I get the value x1 x2 y1 y2? Just solve the equations, right? Y is equals to x plus 4, it intersects this, so put y is equals to this in this place. So I will get x plus 4 whole square is 16x plus 80. This implies that what? X square plus 16 plus 8x is equals to 16x plus 80. X square minus 8x minus 16 minus plus 16 minus 80 is equals to 0. X square minus 8x minus 64, right? 64 and 16 is 80. So what is the value of x? X equals to minus b plus minus square root of b square. B square is 8 square minus 4ac, 4 into 1 into minus 64 by 2a. X is equals to 8 plus minus 8 square. You know, this is 8 square and this is 2 square, so 16 square by 2, which can be written as 8 plus minus, if I take 8 out, 1 square plus 2 square is square root of 5 by 2. So 4 plus 4 root 5 comma 4 minus 4 root 5 are the values of x. So we can assume x1 is equals to this and x2 is equals to this. Now we know that these 2 points also lie on y is equals to x plus 4. Y is equals to x plus 4. So y1 is equals to x1 plus 4. Y1 should be what? 8 plus 4 root 5. And y2 is equals to x2 plus 4. So y2 should be what? 8 minus 4 root 5. So the midpoint C of A and B is x1 plus x2 by 2 comma y1 plus y2 by 2. We know what is x1, 4 plus 4 root 5. We know what is x2, 4 minus 4 root 5 divided by 2. 8 plus 4 root 5. y2 is 8 minus 4 root 5 divided by 2. This cancels, this cancels. So it is equal to 8 by 2 comma 16 by 2 is equals to 4 comma 8. 4 comma 8. It's the correct option. Okay, next problem. So we have now moved to ellipse. There were 2 problems on parabola. We have solved both of them. Third one is on ellipse. If the sum of the distance from the foci to the center of an ellipse is 8 root 6, we know that for a given ellipse whose equation is this, x square by a square plus y square by b square is 1. This is a comma 0, this is minus a comma 0. It is something like this. This is 0 comma b, this is 0 comma minus b. A and b are both greater than 0 assumed in this equation. Now foci are what? AE comma 0 and minus AE comma 0. We also know that where E is less than 1 and greater than 0, right? This is x-axis and this is y-axis. The distance from the foci to the center is origin 0 comma 0. So the distances are what? AE plus AE, which is equals to 2AE. This distance is AE and this distance is also AE. So the total distance is 2AE. 2AE is given as 8 root 6. This means what? AE is 4 root 6, or A square E square is equals to 4 square into 6. We know that E square is what? 1 minus B square by A square. 4 times 4 is 16 times 6. So A square into A square minus B square by A square is equals to 96. Or A square minus B square is equals to 96 is one of the conditions of this ellipse. If you look at the options, this is A square and this is B square. A square minus B square in this case is 100 minus 64 is 36. But for me, A square minus B square is 96. So this is incorrect. Again, 100 minus 16 is 84. So this is also incorrect. 10 minus 4 is 6. Incorrect. 100 minus 4 is 96. So this is the only option which satisfies. If you are giving an exam with such kind of MCQ problems, and if you spot something like this, I would say just mark 4 and move on. But since we have some time here, we can solve the problem completely. Okay, now let us look at the next part of this problem. It is also given that the area of the smallest rectangle in which the ellipse can be inscribed is 80 square unit. Which is the smallest rectangle in which this ellipse can be inscribed? This one. Just touching the ellipse over here, 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 and here, right? So what are the length and breadth of this rectangle? This is minus a, this is plus a. So the length is 2a, and what is the width? This is b, and this is also b, so this is 2b. So what is the area of this rectangle? 2a into 2b, right? Length into breadth is the area of rectangle, which is 4ab. This is class 8th, 9th, whatever question, area of rectangle. This is given as equal to 80. 4ab is given as 80. This means that ab is equals to 20. So now we have two equations and two variables. We can solve. A square minus b is what? 20 by a whole square is 96. A raised to the power 4 minus 20 square by a square is 96. A4, 20 square is 400 is equals to 96 a square. A4 minus 96 a square minus 400 is equal to 0. Now we have to solve this equation. So how do I do that? We can factorize, or what we can do is we can factorize this. Minus 100 a square plus 4 a square minus 400 is equal to 0. Take a square common, a square minus 100 plus 4 common, a square minus 100 is equal to 0. A square minus 100 into a square plus 4 is equal to 0. So a square is equals to 100, or a square equal to minus 4. A square is a positive number, it cannot be equal to minus 4. So this solution I am ignoring. Hence a square is equals to 100. If a square is equals to 100, what is b square? I know that a square minus b square is 96 from here. So 100 minus b square is 96. This implies what? B square is equals to 4. So what is the equation of my ellipse? X square by a square plus y square by b square is equals to 1. A square is 100. So x square by 100. B square is what? 4 by plus y square by 4 is equals to 1. So this is the equation of the ellipse, which I had already shown was option 4. Let us move on to the next problem. Find out the equation of an ellipse with directrix this, focus this, eccentricity this. We know that in an ellipse, again let us draw the diagram. If this is the focus, this is the point, this is the directrix, ratio of, if this is the directrix, so PF by PD is equals to E, right? Distance of the point from the focus to the distance of the point from the directrix is equals to eccentricity of the ellipse. We know that. So if my general point on the ellipse, let us say, is x1, y1, so distance of x1, y1 from the focus 1, 2 is what? x1 minus 1 whole square plus y1 minus 2 whole square root from the distance formula. Eccentricity is given as 1 by 2. What is the distance of this point from a line? So just put x1 in place of x, y1 in place of y, minus 5 mod divided by square root of 3 square plus 4 square. Now how do I solve this equation? There is a mod over here and there is a square root. If I square the square root, is square root sign disappears. If I square the mod sign disappears. So x1 minus 1 whole square plus y1 minus 2 whole square. Square of half is what? 1 by 4. 3 square is 9, 4 square is 16, 9 plus 16 is 25. Square root of 25 is 5. Again, since I am squaring it, so 5 square is 25. 3x1 plus 4y1 minus 5 whole square. Mod sign disappears because we are squaring, so whether it's positive or negative, it doesn't really matter. 4 times 5 is what? 100. So 100 times x1 minus 1 whole square plus y1 minus 2 whole square is equals to 3x1 plus 4y1 minus 5 whole square. Now in place of x1 and y1 you can just put x and y, and that will be your equation of the ellipse. So all that is needed to do is to find out which one of them is correct. You have to open these squares. So 100 into a minus b whole square is a square plus b square minus 2ab, a square plus b square minus 2ab, a plus b plus c whole square, or a plus b minus c whole square, whatever. So a square plus b square plus c square plus 2ab. 3 times 4 is 12, times 2 is 24xy, plus 2ac. C is negative minus 5, so 3 into minus 5 is minus 15, times 2 is minus 30, plus 2bc. 4 times 5 is 20, but with minus sign, so minus 40y. I hope I have not made any mistake. So 100x square plus 100y square, 1 square is 1, so plus 100 plus 4, so 1 plus 4, 500 into times 100 is 500, minus 2 into 100 minus 200x, so this will be minus 4y, minus 400y. I think that is all the terms. Minus 9x square minus 16y square minus 25 minus 24xy plus 30x plus 40y is equals to 0. So 100 minus 9 is 91x square, 100 minus 16 is 84y square, minus 200 plus 30 is minus 170x, minus 400y plus 3640 is minus 360y, minus 24xy, 500 minus 25 is 475 is equal to 0. 9184 minus 170 minus 360 minus 24xy plus, also this option is correct. Okay, now let us move on to the last problem. A rectangular hyperbola passing through this point has asymptotes parallel to this coordinate axis if one is point of intersection of the two perpendicular tangents of the parabola. Okay, so we know that in a rectangular hyperbola, let us say this is a rectangular hyperbola where the asymptotes are x-axis and y-axis. We know that the parallel tangents are intersecting at this center, which is the origin, right? X-axis is a tangent to this at infinity, y-axis is a tangent to this at infinity, and they are perpendicular and they intersect at the center. Equation of this kind of rectangular hyperbola is this, or xy is equals to c. Now the center is given as 1 1, right? Because this is the point of intersection of two perpendicular tangents, so that means this is the center of this rectangular hyperbola. So equation of this rectangular hyperbola is this: x minus 1 into y minus 1 is c. How do I find out c? I know that this rectangular hyperbola is passing through 3, 2. So let us just put these into this. 3 minus 1 into 2 minus 1 is equal to c, or c is equals to 2 into 1 or 2. So the equation of my hyperbola, rectangular hyperbola, to be specific, is this. Open the brackets, xy minus x minus y plus 1 is equals to 2, or xy is equals to x plus y plus 1. Done. So also if you are in the exam and you do not have any idea how to solve this problem, you may still be able to solve it. Okay, I will just show one trick. If you don't know all of this blah blah blah, you can still get the correct option. How? The rectangular hyperbola is passing through 3, 2. So let us just put 3 comma 2 in each of the options and see which one is correct. Option 1, xy will be what? 3 into 2 is equals to 6. Let us look at the RHS. X plus 1 by y is 3 plus 1 by 2 should be 3.5. So 6 is not equal to 3.5. So this option is gone. Okay, next option. X is 3, y is 2. This is the LHS which I am talking about. So 3 into 3 plus 1 by 3, 3 into 10 by 3, this is equal to 10. 10 is not equal to 1, this option is also gone. Next option, x into 1 minus y is the LHS. So 3 into 2, 1 minus 2, sorry, so minus 3. Right, 1 minus 2 is minus 1, so minus 3. RHS is what? Y minus 1, 2 minus 1 is 1. So minus 3 is not equal to 1, this is also gone. By elimination, option D is correct. Let us see what is the LHS. 3 into 2 is 6. What is RHS? 3 plus 2 plus 1, which is equal to 6. So 6 equal to 6. Option D is correct. Even if you do not know the equation of the rectangular hyperbola, you can still solve this question because the options are designed in such a way that just putting 3 comma 2 in these equations can give you the correct answer. But you have to be really lucky to be able to solve a problem like this, because usually the options are designed such that you are not able to eliminate them in such a way. But in case you do not know, maybe elimination will work for you if maybe you are lucky. Okay, so these were the 5 problems on parabola, ellipse and hyperbola. Okay, thank you everyone for watching my video.